In previous video, we have learned about solving the system of linear equations. We have seen how we will be able to convert that system of linear equations into a row echelon form, and how the solution is being done, like computing the particular solution and computing all solutions with respect to x equal to 0, and then combining all those solutions to form the general solution. This much things we have learned in the previous video. Also we have learned about the reduced row echelon form. So reduced row echelon form is like you will be having a pivot column in which the other entries in that pivot column will be 0 and the pivot entry will be 1. So in that column only 1 will be there, the rest of the values will be taken as 0. So similar to how you are converting a matrix to a row echelon form, you will be able to convert the matrix to reduced row echelon form also. So here we have discussed in the previous video itself how we are converting. So in this case, the last, that is after this matrix, you can consider it to be as a row echelon form. It is not considered as reduced row echelon form. Why? Because the value above this second column above the pivot, the value that is given is 9/5. So you need to perform some operation on that row so that this value becomes 0. Okay, so you can make it like you can take the difference like R1 is equal to R1 minus 9/5 of R2. Like that, some operation you can perform so that this value becomes 0. While you are performing such operation, make sure that the other entries, this 1 also, it should not get changed. So when you perform the operation, this 0, here 0 it is there. So 1 minus 0 into 9/5 means you will be getting the result as 1 only here. And here 9/5 minus 1 into 9/5, if you give means, while after subtraction you will be getting the value here as 0. So the resulting matrix will be 1 0 0 1 0 0. So this will be the resulting matrix, and in this case pivot column is having one non-zero value, and the rest of the values it is treated to be as it is 0. Okay, so this is a reduced row echelon form. So reduced row echelon form will be having an entry called pivot, that is a non-zero value, and there's only 0 entries below it to its left. Also 0 rows. So this is the case with the row echelon form. Okay, reduced row echelon form is like the matrix should be in row echelon form provided the column of the matrix in row echelon form, it will be having a pivot which is called a basic column, and if it does not contain any pivot, then we call it as non-basic column. Okay, so this non-basic column will be like it will not be having any pivot, and pivot will basic column is like it will be having a pivot. So reduced row echelon form, in what are the conditions? A matrix should be in row echelon form provided the pivot column it should have a non-zero value, and the other values will be 0 in the pivot column. So we can see an example here. Here a matrix is being given. So here the value is 0. And here we will be able to identify the pivot as these values, and the pivot column also we will be able to identify. So from this, how the solution can be done. Here the B value is not given, just that A matrix is given. Since B is not given, you will not be able to find the particular solution. So in this you will be able to find the solution for Ax is equal to 0. That is all solutions that is possible for the equation Ax is equal to 0. So since it is in reduced row echelon form, what you can do is identify the non-pivot columns. Okay, non-pivot columns is this one, column 2 and column 4. So next what you need to do is you can express or you can represent this non-pivot column using the pivot columns in some way, either by multiplying or by taking sum of the pivot columns. You will be able to represent the non-pivot column. So for example, consider the column 2. So this column 2 you will be able to get if you multiply column 1 by 3. Okay, so here only column 1 is considered. Why? Because a pivot you need to represent you need to express the non-pivot column using the pivot column that is coming in the left hand side of the column that we are considering. Okay, so non-pivot columns will be represented or expressed in terms of the pivot columns that is coming to the left hand side. So here C2 we need to express. So the pivot column that is coming to the left of C2 is C1 alone. So in some way we need to express the C2 with the help of C1. So we can express like this. C2 gives C2 will be equivalent to 3C1. Okay, so this equation we can formulate an equation like 3C1 minus C2 gives 0. That is, in this format you are formulating. So if you formulating an equation, you will be getting 3C1 minus C2 equals 0. Again, so C1 means what? C1 is 100, C2 is 300, will be equal to the vector 0, 0, 0. So from this you will be able to get a solution like how you will be getting the solution means you need to get the indices, that is index value of this C1 and C2 you need to take. So C1 index of C1 is 3, which represent the x1 value, so place it over here, and C2 index is minus 1, represents the x2, place it over here. Then here column 3, column 4 and column 5 is not given in this equation, so it represents a 0 over here. Okay, you need to place 0 over here, which represents the variables x3, x4 and x5. Similarly, you need to do for the next non-pivot column, that is C4. Okay, so this is one possible solution that you got. Similarly, you will be able to get solution, and also here one scaling of this vector will also give the solution like equal to 0. Okay, so lambda 1 of this solution vector, also it will be resulting into a solution for this linear system of linear equations. So lambda 1 is an element of a real number. Then similarly, from the matrix you need to take the next non-pivot column, that is this one is not the non-pivot column. C5 is the non-pivot column. Okay, C4 it is a pivot column, C5 is the non-pivot column. So C5 left, how you will be able to represent? Towards the left of the C5 we are having the pivot columns C1, C3 and C4. So based on these three columns you need to express the C5. How you can represent? How you will be able to represent, that is 3C1 here. Okay, 3C1 plus 9C3 minus 4C4 is equal to C5. Okay, C5 can be expressed as 3C1 plus 9C3 3 plus minus 4 C5. Okay, so moving this C5 to the left hand or right hand side, what you will be getting? You will be getting this equation. That is 3C1 plus 9C3 minus here you will be getting C4, isn't it? This column it is C4. So minus 4 C4. Minus C4, 4C4 minus C5 will be equal to 0. This equation you will be getting. Now substituting the values, simply you are just substituting the values. C1 is 100, C3 is 010, C4 is 001 and C5 is 39 minus 4. Substituting the values, it will be generating a vector that is 0. So from the equation itself, you will be getting the general solution, seeing the indices of the columns. So here C1 index of the C1 is 3. So place x1 will be equal to 3. Then C2 column is not there in the equation. So x2 will be equal to 0. C3 is 9, x3 equal to 9, C4 is minus 4, x4 is equal to minus 4, C5 is minus 1, therefore x5 will be equal to minus 1. So you will be getting one solution, and scaling of this solution also will be generating the vector 0. So lambda 2 of 3, 0, 9 minus 4 minus 1 is the next solution that is being generated. So finally you can generate the solution of Ax is equal to 0x. Ax is equal to 0 as x is an element of R5. How you got this 5? Because we are making use of 5 variables, x variables we are making use of, where x is equal to lambda 1 of the first solution you are taking plus lambda 2 of the second solution. Okay. So these two solutions combine together to get the solution for the Ax is equal to 0, where lambda 1 and lambda 2 element of R. So in previous one slide we have seen this problem. Okay. So in that case we have learned what is this x values. That is these x values, they are treated as unknowns, and you need to find the x1, x2, x3, x4. Those things we have learned. Now with respect to this, what we have learned, that is reduced row echelon form, you will be able to find the general or the general solution for this problem. So the general solution can be found how? First you need to find the particular solution. So in this case the right hand side is also given. So how we can find the particular solution? So you need to take like this. B is equal to 42, 8, and here it is in reduced row echelon form. So 42 column 1 plus 8 column 2 it will be taken. And what is the equation that is being generated? 42 C1 plus 8 C2, isn't it? The C1 will be representing x value, so x1 will be 42, and C2 here it is taken, so 8 will be the x2 value. Remaining C3 and C4 is not specified in the equation, so it becomes 0 over here. Okay, this transpose is given because it represents a vector, so that is why it is taken as a transpose. Okay, so the notation will be like 42 8 0 0. Like that you need to write the matrix. It represents one column. And similarly you need to find the other solutions. So this is a particular solution for Ax is equal to B. Now you need to find the solution for Ax is equal to 0, similar to what we have done